Hello, Maurits here. So in the last video we defined the derivative f prime of x as the limit as h goes to 0 of f of x plus h minus f of x over h. And that is basically the limit as delta x goes to 0 of delta y over delta x. And we should now use this to find a few derivatives. And we should look at a fairly silly example to see that just works. So say we have our function f of x equals to, say, 3x plus 2. And since the derivative was a function that gives us the slope or the gradient, in this case this gradient is 3 all the way through, so f prime of x should be just 3. So let's see if this works for our definition. So we say that f prime of x equals to the limit as h goes to 0 of our function, but x plus h plugged into that, so that will be 3 times x plus h plus 2 minus 3x plus 2. So this first part here is then the f of x plus h, right? And this part here is our f of x. And we divide that by h. If we would try to plug in h is 0 into this, we'd get 3x plus 2 minus 3x plus 2 divided by h. So we would divide by 0. We get 0 divided by 0, which is undefined. So we can't do that directly. But we could simplify our expression in some way. So the limit as h goes to 0, let's expand the thing we have here. That will give us 3x plus 3h plus 2 minus 3x minus 2 over h. You can see that the 3x will cancel against the 3x, and the plus 2 will cancel against the minus 2. So now we have the limit as h goes to 0 of 3h over h, and here we can cancel the h against the h. So get the limit as h goes to 0 of 3, which obviously is 3. So this was a very silly way to find that the slope of 3x plus 2 is 3. But the main reason we did this was just to check that this actually works. So let's try with a slightly more complicated example. And we can first say I draw the function, say f of x equals to x square. So 1 will give us 1, right? And 2 will give us 1, 2, 3, 4. And minus 1 will give us 1. And then we have 4 again, right? So we get graph something like this. And if you do this a bit carefully, we can see that it seems to be that the slope over here is about 2, and the slope of there is about 4. The slope here will be minus 2 and minus 4 and 0. So it seems, if you draw this carefully and check this, it seems that the derivative, the function that gives the slope, with 2x. We can particularly see that for 0, right? If I plug in x is 0, the curve down here has the slope of 0. It's flat, so to speak, down at the lower part. And 2 times 0 is 0, so that works fine. Let's check this. So if f of x equals to x squared, then f of x plus h is, of course, x plus h squared. So we get that derivative f prime of x equals to the limit as h goes to 0 of x plus h squared. So that is our f of x plus h, right? Minus x squared, that is our f of x, divided by h. And if we try to plug in h is 0 to this, we will see that we get 0, 0, so we can't use that directly, but we can try as before to do a bit of expansion and simplification. So limit at h goes to 0 of square plus 2hx plus h square minus x square over h. You can see the x square will cancel against x square. To get the limit as h goes to 0 of 2hx plus h square over h. We can here see that we have a common factor of h in the numerator. So limit as h goes to 0 of h times 2x plus h over h. These two cancels, right? Get limit as h goes to 0 of 2x plus h. And here we don't have any problem whatsoever to plug in h is 0. So that will simply give us that the limit is 2x, just as we guessed in the beginning. So the derivative of x squared is 2x. And one way you could write that is to say that x squared prime, so the derivative of x squared equals to 2x. So we can say that will be our first little rule. If we encounter x squared, we know the derivative is 2x. So hope this helps a bit. We should look at a few further examples in the next video.